Picos and Pico Ws make great battery powered devices. How do we monitor the battery though? If I'm using something like a Lipo shim to charge the battery, then how do I know whether it's on charge? Let me show you how. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, robotics, IoT and other fun tech. Remember to subscribe and join the community. Monitoring the power source and voltage of the battery is quite easy on a Pico. It's just another ADC source, analog to digital converter, just like the onboard temperature sensor. It gets a little bit more difficult with the Pico W, as including Wi-Fi changes some of the design. I've got examples though that show how to do this both with and without Wi-Fi. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video? I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there, and I hope to see you there too. Please hit the like button on the video and subscribe for more. So I'm planning to build a solar powered project, and that means that I will of course need some battery backing that to give power for the project overnight where we don't have any sun. Of course in the UK I can't really guarantee the sun. We get plenty of cloud and rain, so I want to be able to monitor the state of the battery and see what its health is and see whether my charging strategies are actually working. The 500 mAh Lipo battery I used in this video was purchased from Kunkune, who are also the sponsor for this video. Kunkune are a friendly online retailer in the UK for modules, components and tools. Kunkune have kindly offered a discount to my channel viewers on the first order. Just quote Dr Jon EA Ltd at checkout to get a 20% discount. This excludes electronic test equipment and tools. Go check out Kunkune today. Out of the box, a Pico can take power from two sources, from VBus, which is actually the same as the USB and it's normally at 5 volts, but we can apply it either to the USB cable or via the top right hand pin on the Pico. And VSys, which is normally coming from a battery, and quite often it's actually a range of voltages somewhere between 1.8 and 5.5 volts. So VBus and VSys is really commonly just what's coming in on the USB cable, and VSys is what we're going to take in from a battery. On a Pico we can use one of the GPIO pins, well actually one that's not exposed on the outside but is available to us in code, called GPIO24, to understand where is the power source. If GPIO24 is high, then our power source is coming from VBus and it's probably a USB cable. If GPIO24 is low, then it's coming from VSys and it's probably a battery. Now when they created the Pico W, they had to make some slightly different choices around which GPIOs were available and used, because obviously they had this additional Wi-Fi chip they suddenly had to get interfaced properly to the Pico. So to do that, they've actually unfortunately changed the way that we sense which is the power source on a Pico W. So instead of using GPIO24, you actually use a special GPIO pad off of the CYW43, actually off of that Wi-Fi chip. And that GPIO2 off of the CYW43 gives us a sense of whether the power is coming from VBus or VSys. Again, high would be its VBus, low and it's VSys. And we can use the command CYW43 arch GPIO get to actually pull back this value with the parameter CYW43 WL GPIO VBus pin, i.e. what's the VBus pin? The VBus sensing pin. A recent update to Pico examples actually added an example directly doing this. Let's just have a quick look at that. So in the Pico's examples project, in the ADC, analog digital converter section, there is a read VSys example there. And this has actually got a nice little library built in there called power status. And it's this that I want to just quickly show you. If we have a look at the power source function, we'll find that calling this function, if you are on a Pico W, i.e. that variable is set, then it's using that CYW43 arch GPIO get to pull back this value to tell us whether we are getting power from VBus or VSys. Actually, this code will run on the Pico and the Pico W because we've got this if statement here. And so if you're actually on the Pico, then you run this code down here and it will actually pull back what is GPIO 24 and use its value to set this and return this value for what the actual source of our power is. And the way it's written is a decision of, is this actually battery or not? And by battery, they mean, again, VSys. The Pico and Pico W have just a single analog to digital converter, ADC unit. Of course, there are multiple ADC inputs, and what we actually have to do is select which one of those the ADC is pointing at. And of course, GPIO 26, 27 and 28 are all external pins that we can use as ADCs. There are a couple of internal pins as well though. GPIO 29 ADC3 is actually the onboard temperature sensor, and I've done some videos on that. ADC4 GPIO 30 is actually the voltage sensor for sensing the voltage on VSys. So this is how we can actually work out what the voltage is on our Pico. Now, once again, actually this pin is reused and differently on the Pico W. It's still available for VSys, but you have to do some other things first because this pin is used for the SDI clock into the CYW43, and that's going to cause us some problems. Now, theoretically, you can control whether that clock is enabled and whether you can use that pin using GPIO 25. When I actually went through these demos though and tried to write some code to do that, I started to have some problems with that and finding that actually it wasn't always very reliable. And then I started looking at that Pico examples project, and there's a great function already in that Pico's examples project that does all of this, and it works every time. So I've moved and just using that. So let me just show you that. So the function power voltage here actually reads the voltage of VSys, and it should work on both the Pico and Pico W. Now, how exactly this is working and how this is managing across those pins to actually work to control the sampling for VSys and whether that pin is being used for the SDI into the CYW43 or not, I'm not entirely sure I quite get, I must admit. But on the other hand, in every test I've done with Wi-Fi up or Wi-Fi down, this actually works really, really reliably. So here's the exact code to do it, to work out what is the power voltage on your battery. So I've put a little project together on GitHub which demonstrates me using the library from Pico examples to actually get this power source and power voltage. And I'm going to do it a couple of times. One, simply just call it, and one actually do it in combination with running an IP stack and a web services. So the simple example really is just going to, let's have a look at the code here. It's basically just going to run a loop working out what is the power usage on a Pico W. And I am using a Pico W. I am actually initializing a Pico W up here. So I'm just going to say, well, are you getting power from VSys or VBus? And then what is the voltage that we're actually reading to 2 decimal places? Then go to sleep for a second. And I've written this to actually pick up and use the library from the Pico examples path. So in the cmakelist.txt file, I'm actually referring to this environmental variable Pico examples path and picking up that power status .c file and the include folder from that project. And why that project isn't in Pico Extras and there as a library, I'm not sure, because it's an extra little function and a couple of functions there. So I've actually referenced it like this using the environmental variables. So here I'm measuring the voltage coming in on VSys and just printing it out. Now I've got my Pico W connected up to a bench power supply, which means I can actually turn that voltage down and up and see the effect of it on my Pico. So I just wanted to check an example where actually I've got web services up and a complete IP stack to make sure that actually this code isn't interfering with that. So what I'm actually going to do is read the voltage source and voltage itself and send it over to a web service, and that web service will then send me back exactly what I've submitted, but now as a JSON message. So I wanted to do this Pico's web services example just to really check and verify that everything really does work nicely in a proper Wi-Fi context. To be able to actually read the battery voltage. So all of this code is doing is using some of my other example code around web services and how I do web services in C++ on the Pico. So what I'm actually doing in the code is basically just taking the power voltage and power source data, and then I'm giving my web service 3 parameters: the current time, as I understand the time that I've been up as a Pico W, the power source, where it's coming from, which is a string, and the voltage. And I'm just going to send those all over as parameters into my web service. So my Pico W here is just connecting, and then it's going to start sending these messages over to the web server every 10 seconds. And it's sending as parameters that time it's been up, what its source of power is, and what the voltage is. And you can see that the results are coming back, and that on that result line is actually a JSON string that's been provided back by the web service. If you'd like to know more about web services and using them from the Pico W in C++, and why wouldn't you, then check out my course over on Udemy. There's over 6 hours of lectures, 28 examples in C++, and gives you all of the skills with building, exploring and debugging web services. Go check it out. So our battery is going to go, of course, from the full charge through the decharge cycle right down to a low charge and then charge back up again, or some combination of that. How do we actually know where it is in that cycle and what's going on in the state of the battery? All we've actually got is the voltage. So I did a few tests on this using a 500 milliamp hour battery, 3.7 volts. And as you can see here, the voltage actually starts way over 4 volts and is a pretty linear decay really as it moves through. You don't really see it start to fall away very rapidly until it drops below 3.4 volts. So I could probably just put on a simple test to, when I drop below 3.4 volts, I really ought to raise an alarm that my battery is actually now dangerously low and I probably will lose power within the next few minutes. I'm not sure why these functions have not been made into one of the Pico's libraries. They are nicely written and show how to measure the battery voltage. Due to the licensing being used, I've not copied and pasted them into my own code, but actually used them as a library. And you can see how to do that in my example too. If you like the video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. Remember, I'm saving these up to get myself to open source in San Francisco next year, and I appreciate your help in getting me there, and I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please do hit that like button and please subscribe to the channel so you don't miss the next video. Bye bye for now.